part of this webinar, and that is comments and discussions. And then I open for comments from Patrick Andreasson. Right.
Yes, thank you. Yeah, I have some questions also, but maybe I can incorporate them into my comments here. Let's look at the watch here. If I start with both of you, I enjoyed both presentations. I'm not an expert in any of the areas, but I really enjoy them. If we start with a cure there, and you have to excuse my ignorance perhaps, but you mentioned that the first thing I think about is that you mentioned, I think at the end, that it was important to make this affordable to use. You also said that I think in a response to a comment that we need to have a concept developed or partly developed just to evaluate it, and I agree with that. But I try to see at the cost here, and if I estimate it roughly, I mean 250,000 cubic meters rock excavation. It's at least a few 100 million Norwegian or Swedish crowns to do that. Probably more, since you have a pressurized system here. And I also looked at the power consumption for the air pumps, and if I did it correct, I think it's at least tens of gigawatt hour per year required. So it's a lot of costs. On the other hand, it's kind of a nice way to create this dampening. But I guess it has to be evaluated, as was mentioned here, with passive dampening and those kind of measures, but also the earnings of hydro peaking. So is that? Can I ask questions also?
Yeah, yes,
Yeah.
yes.
Is that something that you will do in the coming time or coming years? Look at the costs.
Are you asking me?
Yes, that's the question to you, Umid. Yes.
Yes, the other part of designing, it's, I think, till March. Until March, I think the final timetable. But I'm trying in the next few months, I will prepare other detail, such as a air vacuum, air pump, or some other details about the consumption, energy consumption, and some other detail. I will prepare it and complete the report.
Yeah. What I see from your computational part, I mean, it's from a technical side, it's quite straightforward how it works, and I appreciate that you actually do this in freeware and that you actually have this graphical user interface for us others to use. So that's really good. I look at the time now. Maybe I have to have a question on the other part also, and then I really enjoy this. And I have several questions. I have to choose one here.
Yeah, yes.
Well, just a comment. I think to refine the modeling, that's of course the obvious thing for a researcher to get high resolution in space and time and so on. But in a sense, from a user perspective, it's really nice to have a rather coarse model that is you as I understand it, parameterize hydro peaking events. You kind of have this model that you can run for a long time with not so much computer effort. So I would urge you to not abandon the coarse modeling. That's to me very interesting. What I was thinking about is it possible also to introduce a change in the model? For instance, if you introduce connectivity or something like that. So you can see actually the process of changing for a population to start to grow in an area where they have not been before, etc., etc.
Yeah, it's quite an easy model to do. I mean, we firstly went for a coarse resolution because we wanted to model for long time periods, because whether a population thrives or declines often takes decades, or it can be over a 50-year period. So we're going to stay with that, but use finer resolution data from outside where necessary to model the functions. It is possible to, I mean, it just involves, if you wanted to do like a structural change in the habitat, it's easy just to write another R function and just to put it in there, and we've done that before on certain occasions. So we were modeling the Mandalselva in southern Norway, and it had some specific characteristics to do with a minimum flow area, so it's easy just to put that in, and then you can see how a population responds to a change in circumstances at a certain location and a certain point in time in the model.
Okay, interesting. I'm really I would really like to try this in Vattenfall also, IB Salmon.
Yeah, thank you, Patrick. Okay, Staffan here again, and yeah, I tell everybody that didn't hear that my camera in my computer is not working, so therefore you cannot see me or Patrick. We're sitting in the same room. That's never happened before. But let's anyway move forward to the next, and that is that will make comment. That is Birgitta Malm Renefelt och I think Åsa Widén, that you have chosen to make the comments together, right? Yes. We see you now.
Yeah, okay,
Here
good.
we are.
Yeah. Nice background, isn't it?
Yes, yes.
Yeah, okay, we will try, since we work with the same.
Sorry, you're from Umeå Universitet, so that I forgot to say that. Yes, right.
Yes. And yeah, if Patrick says that he's no expert on this, we are definitely no expert. We are not hydropower engineers, and we are not really fish biologists either. But it was really interesting to hear about both presentations. And I wrote down a lot of questions, and some were answered already before with the other questions that came. So my comment or question would be on the applicability of both the Accure system, but also the widespread applicability of the modeling that was presented in the work with the framework directive and the current process with the relicensing that is going on in Sweden. Do you see great usefulness there, since I imagine that the modeling is quite data extensive, it's quite specific for a certain place, and you have to do it again and again for many places. So how do you see the large scale applicability of this? That's one question. And also more specifically for the Accure, how you comment a little bit about it, that maybe it's not really possible to do in the Ume River because it's such big, the water volumes are so big. So how applicability is that in large scale hydropower, where you have very large water volumes that you have to work with? So yeah, that's one question. Maybe I should let you answer that first. We start with the Accure.
We cannot hear you, Omid.
Okay. Oh, sorry. Did you hear anything?
No,
We heard you, Åsa.
Okay.
Yeah.
About UMA, because we didn't have the volume water that UMA River need, we assume based on the outflow of the hydropower, because it was so huge, it's more than 1,000. And
Yeah.
because of that, we assumed the one shape and calculate based on that assumption. We said, okay, this is so much. See, the Occur work based on volume of water demand in downstream. You know, this is the main rule in defining the volume. Okay, how much water you need for downstream, then Occur proceed and analyze this water and reduce this water to a storage and by the mathematical method. First of all, you have to know how much water you need in downstream.
Yeah, I understand that.
Yeah, for Umar, we didn't have it. We assume based on the
But,
1,025 cubic meter, we assume one shape and reduce that shape, but it's still big value. And then we concluded.
Okay, so in your opinion, how large would the scale of the hydropower plant be? What is realistic? Is it only small scale hydropower or?
This is, the original design of Occur is based on high head hydropower, okay? But I would say, as I mentioned, how much water you need, you know? Maybe the river downstream of the hydropower need less volume water and it is so affordable, or need so much water. And it's not affordable to build this huge storage volume.
Yeah, that was really a little bit my point. Is it maybe more suitable for the Norwegian system or type of hydropower compared to
maybe depend on demand, depend on how much water you need for this system. Maybe for Sweden, Norwegian, or any country. But first we should know how much water you need. What's the shape? What's the problem of the downstream of river? We cannot decide based on the just shape of the hydropower outflow or something like that. We have to need more analysis and more data.
Yeah, I think Staffan here again. I think that this is a very good question and something we need to elaborate even more in the project. We have 1.5 years left that we can work, and we also now have this. We're really going into the email, so this can be very interesting. So it's a good question. Yeah. So.
Åsa, do you want to take the next?
Okay, I have another question, and since you are presenting a problem with stranding risk, which is caused by reduced discharge, and in some hydro plants, maybe you can solve the problem with environmental flows. And you can match the costs with environmental flows and long-term cost for building a cure system. So have you in the project analyzed these kind of solutions, or do you just focus on a cure?
Just focus on Occur at this stage. We just focus on modeling Occur and how much water, how much space actually we need for Occur.
Okay, just a technical solution.
Exactly, because it's an underground reservoir, pressurized underground reservoir, and reducing this volume is an influence on huge value on the cost, on maintenance, and on everything. Let's focus on this part of.
Yeah, but
we had recently, just a couple of days ago, finished a project in Ljungan, where we have a problem with stranding risks for salmon and trout. What we did in the environmental flow models increased the storage capacity for the upstream reservoirs, and it gave us really excellent results, and we could, in the models, avoid the stranding risk. That's why I asked for how you attack and present different solutions. But
This part is actually gave to me. Yes, of course, that solution maybe is possible, but this whole system has a different department and has a different part. For my part, they said calculate and estimate for this solution. You know.
Okay.
But Staffan here, Omid, I mean, there is a connection to the modeling done by Knut and then also to Richard.
Yeah, we can compare it. We can compare it after.
Yeah, I think this is what will be done now. At least that's my thought in the project. That your modeling will be connected to Knut, and that's already shown, and then also to what Richard is doing, and then there could be a loop. So in that sense, there will be a connection between the Accure and the environmental flow. Is that what you think, Åsa? Also.
Oh, yeah. Åsa, yes.
Yes. Yeah. That's right, Richard. That is the thinking.
Yes, that's great.
Yeah, I have another question regarding Accure. I know that you have just modeled the actual technical solution, so maybe this is more general for the whole project. But Accure is specifically, as I understand it, designed to meet the need or what to say, prevent the stranding of the organisms. But can you also speculate on its ability to keep like a movement in the water downstream? How long? Because we have discussed on as also presented different environmental flows, for example, to forbid zero flow events altogether, or to have time limits on zero flow events, coupled to not to continuously have a water movement to support aquatic organisms and processes. So what's the ability of Accure to keep the water moving? Is it only for a short time?
No. Accure, based on the system, Accure can produce continuously. With a strand line, you can. I showed that the client line goes to zero, but also it can work in a strand line. But it's depending on how much water you need for that river continuously. 10 cubic meter per second, 1 cubic meter per second, or 100 cubic meter per second. Okay, depend on the demand. Yes, Accure technically and numerically can provide continuous.
Just perform with a continuous.
Yeah, but this is depend on how much water in the end, you know. But we have to calculate how much water. But yes, Accure can provide it continuously for the river.
Okay.
So, Birgitta and Åsa, any more comments? I thank you very much. And are there any other questions or comments? I think Patrik has here some comments.
But if somebody else has, please. Maybe I take my question then.
Yes.
I think I was really intrigued by this IB salmon model. I haven't heard about it earlier. I have some experience, or at least I tried to learn a bit about EDM. And we also have in Umeå, about at the Agriculture University, SLU, Kjell Leonardsson, who has worked with a population modeling, which is, as I understand it, it's more for connectivity and has no real upstream, downstream information of the regarding flow or velocities or whatever. But if I understand you correctly, Richard, you could use IB salmon in a similar way, but you get this information, which is important. For instance, if you have to pass through a reservoir, the fish. Now we are just talking about smolt, but if we talk about fish in general, has to pass through a reservoir also and find spawning grounds, etc. But that will be possible.
Yeah, that's right. We've used it in like a range of situations. We've been looking at hydro peaking. We have in the past looked at e-flows and changes in habitat modeling, or changes in like habitat remediation methods and changes in water temperature. So we're predicting possible climate change effects. So it can be used in that. The problem with this model and that limits its ability to generalize is that it because we're looking at the effect of local scale variations in the habitat, it does require fairly detailed information on the habitat properties and fairly reasonable information on the salmon population if you want to get like a robust estimate. But it is fairly easy to modify it.
Yeah. When you say to estimate it, you mean to validate it, or can you do an estimate although it's not validated? Can you?
Yeah.
Scenarios and so on.
Yeah. So I mean, how good the data are, how good the data you require depends on how fine a simulation you want to get, or how good a simulation you want to get, how realistic a simulation.
Thank you.
All right.
Thank you.
Any more questions or comments before we finish this very interesting, as I see it, webinar? All right.
Can I,
Yeah,
can I just add a last
of course.
question? In this whole project, have you thought anything about climate change and how this will affect the needs, whether they will increase or decrease, or how they will affect the ability to run the Accure, whether we have extreme events for long dry periods and so on? Have you thought anything about climate change in regards to the whole project, I guess?
At this stage, no, but for the final designing, of course, for example, for next 10 years or next 50 years, for the long term, we have to consider these influences on the reservoir volume and the equipment. Yes, in the final design, yes, but at this stage, no.
Yeah.
Okay.
Yes, I agree on that stuff on here as well. That I had to think about it because it's so much now of climate change and other projects that we are discussing. but in this project is very much up to this flexibility, the very fast flexibility, like 30 starts and stops. I can say that in this project we also have the University of Ashland that has been looking at the needs in Europe of electricity. And based on that, how much the power stations, the hydropower stations in Norway and Sweden should be run, and they have not found this 30 starts and stops. They cannot really see that based on the need of electricity. But climate change, we think about, but it's not really a part of this project, right, Richard, or anybody else in your modeling right now in Hydroflex, you are not thinking about the climate change.
Not in our aspect. I mean, climate change obviously will have a big effect, and we have modeled climate change effects with this, but not within this. And we're dealing with a regulated river, so maybe the effect of climate change isn't going to be so big because you can control the flows.
But we don't agree with you. We've been working with climate change and hydrology and runoff in regulated rivers, and it really affects.
Yes.
Oh well, yeah, I'm wrong then.
So, and that's our main conclusion, that you might think it won't affect you, but it will. It will affect the hydropower production, and it will affect the ecosystem. And for some of these rivers and the catchment areas that we've been studying, we see that dry years and dry events will be super dramatic. And if you have, if you will have maybe 2 years very close, 2 dry years really close, it could be really problematic.
Yeah.
Okay.
Oh,
But
that's interesting.
For the ecosystem, but as for, even for the hydropower production, it could be dramatic. So it's a 2-fold or 3-fold problem.
Okay, thank you, Åsa. I think this is super interesting, the climate change, and that is something that must be included more and more in the thinking.
We construct hydropower and environmental measures for the future, not for historical stationary conditions, because in the future we will have non-stationary conditions.
Yeah. So this is both big difference on the long scale, and then like hydroflex is really on the short term. So yeah, very good. Okay, then if there are no other questions, we have also gone 3 minutes over time, so I think we stop here. And again, thank the keynote speakers very much for the very interesting presentations, and also the comments by Patrick, Åsa, and Birgitta was very nice, and the rest of you also that have a lot of questions. So thank you very much. Very nice webinar, I think, and yeah, bye-bye.
Thank you.
That's great. Thanks.
Thank you. Bye.
Thank you.